We'll be talking about building a REST API, and then we're going to focus on two different parts with this talk. The first part will be what makes a good REST API, and the second part will be let's actually use Zend Framework too and use the abstract REST controller to build a nice API that we can use, and then we'll talk about some other solutions as well. As you mentioned, I am a developer advocate with Constant Contact. I promised them I'd say their name at least 3 times. Well, he said once, there's one more to go. But I just want to give them a quick shout out because they made it possible for me to be here. They got me out here, they allowed me to talk, and they also sponsored. So just credit to them. And also big credit to the volunteers, the other speakers, the sponsors, and the organizers for making this happen, because putting together a conference like this is really, really hard. So if you see Steve, you see Justin, give them a hug. I don't know if they're huggers, but they'll appreciate it. Maybe. So anyways, what we're going to talk about, the first thing we're going to look at is what is the purpose of an API, different API technologies and techniques. If we're going to use a REST API, why are we going to do that? We're going to talk about the REST methodology in general, components of REST, good practices and not so good practices, OAuth, and then we'll actually jump into building the API itself. So the first question, of course, is what is an API? And I was going to put together this awesome definition, but I decided, no, it's right on the web. I'll just use Webopedia's very plain, very clear explanation of an application program interface is a set of routines, protocols, and tools, and blah, 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 right? So what really is an API? An API is a way to connect your web application to another computer. Whether it's going to be another web application, whether it's going to be somebody's personal computer. But what you want to do is connect in such a way that data remains secure. You don't want to connect it in such a way that, hey, they have access to your databases and they can modify whatever they want. You don't want to create a system where they can log in and steal millions and millions of credit card information and end up like Target. Got to give a shout out to my Minnesota companies. So there are different types of APIs we can use. How many people have heard of REST? You guys are so enthusiastic for this meeting or session. How many people have heard of SOAP? How many people have used SOAP? Okay, how many people take showers on a regular basis? I only got 3 hands on the last question. That's a little bit concerning. So SOAP, and then also RPC. One thing we'll talk about here is RPC gets confused with with REST quite a bit. So the first one is RPC. RPC is your very simple URL / delete / ID. That's it. Or URL / create member / and they pass the information along. The problem with RPCs is they're very tightly coupled. First off, you have to know the path. You have to know the procedure names. You have to know the specific parameters. And a lot of times with RPC APIs, you have to have the parameters in the exact order. So if you pass the first name before the last name, reverses everything, blows everything up, world ends, it's a horrible situation. And then it requires a URI per method or function. So in general, there's lots of JSON RPC APIs out there. They're not ideal for longevity. They're great, really easy to use, but if you want one that's going to evolve with your application over time, try to avoid them. The second one is SOAP, which was very widely popular at one time, but SOAP has lost grounds for a lot of different reasons. First, with SOAP, you expose your methods or operation calls. Each call you make to SOAP is contacting a method that's going to be accessed. Also, it uses larger packets of data. How many people like XML? Okay, for what purpose? Yeah, it depends on what you want to use, but XML can be very easy to read, but you send a lot of data to accomplish the same thing that you could do in like JSON. You're going to be using all calls that are sent through POST. The nice thing about SOAP is it can be stateless or stateful, and then you have your web service definitions. So a sample SOAP request here, what we want to do is we want to get a stock price. This is all the information we have to send to get a simple stock price. And then we'll get that price back, and there it is. We sent all this information and got all this information back to get 34.5. That's our entire data. And that's one reason why we're going to try to stay away from SOAP, try to stay away from XML. REST, on the other hand, returns data and doesn't expose methods. You're not telling them how your backend works. It supports both XML and JSON, as well as other content types. So for the people who like XML, you could send an XML request and get XML back. But if you want JSON, you can do a JSON request, get JSON back, And the great thing about Zend Framework 2 is it makes it very, very easy to say, send this back or send this back based on what they request. It uses explicit HTTP verbs, which is both good and bad for a couple different reasons. The reason it's good is because the user is telling you explicitly what they want to do. You're not saying, I'm going to make this post request, and maybe I want you to delete it, maybe I want you to add it. You're saying, hey, this is a delete request, delete it. This is a post, I want you to create it. It's also AJAX friendly. It allows you to use point-to-point connections. And one of the nice things is it's stateless. Especially if you're using multiple servers, you don't have to worry about keeping sessions. Very simple to do. So a sample REST JSON request. We're going to send in this information to create a new user. That's all the information we have to send. We're actually sending less data to create a new user than we are to get a stock price using SOAP. And then in return, we can get all the information, and then we get more information, again, and less data being transferred. So that's one of the really nice things about using REST-based API using JSON. So basically, the battle between REST and SOAP. REST returns the data very nicely. It gets the win. It supports XML and JSON. It's going to use CRUD or HTTP verbs. Where it doesn't win out is with SOAP, it can be stateless or stateful. SOAP also has the WSDL, which is very, very nice for getting your definitions of this is what I can do. The nice thing is there's some things we can do with REST-based APIs to accomplish that as well. So advantage goes to, any guesses? I couldn't hear that. REST, yes, thank you. You guys gotta get ready because there's gonna be the party tonight, drinking, skating tomorrow. Saving my energy. So now there's some arguments against REST APIs. You guys have probably heard these. REST APIs are difficult to build and maintain. And there's some truth to that. REST is not secure. Anyone can access it. There are no strict standards for REST APIs. And REST services are not reliable. So we're going to build one in 30 minutes, and actually less than that. And the nice thing is, as REST has gained in popularity, there are more tools we can use to help us with documentation to keep it up to date. How many people have used the Constant Contact API? Yeah, this is like my sad moment where it's like, oh. So several months ago, we had an old XML-based API. And the documentation on that was horrible because it fell out of sync and people tried to do things and it didn't make any sense whatsoever. And that's one of the biggest challenges with APIs is making sure your documentation is up to date. And the nice thing is as tools have advanced, we can actually use JSON in our REST APIs and our code to have all the documentation synced up with what we're doing. So there's a lot of great tools we can use for that. And then also, as long as we follow basic guidelines, it's really easy to really meet the needs of our users and maintain backwards compatibility. How many people here have used the Facebook API? Okay, a couple people. How many people like using the Facebook API? It never breaks on you, right? Seems like every week they're breaking something. That, and I'm going to get myself in trouble for saying this, but that's not a properly designed API. A properly designed API should not break backwards compatibility. REST is not secure. There are many precautions we can take. There's so much that we can do now to make it secure. For example, having an API token that they have to use, or API key, using OAuth tokens, following with IP procedures so you can actually limit down to who can access certain things of your site, having different endpoints that are only available to certain users based on their API key. So this really isn't the case anymore. It actually never was the case, but it was one of those arguments where, oh, so you can do this or do this. No, it's still very secure. The issue that comes in with is if you're trying to access a secure API call via AJAX and JavaScript, and you put your API token or key and your secret right in the JavaScript and say, hey, let's make this call. That's not a good idea, because obviously it's very easy to get as its front-end code. There are no strict standards for REST APIs. This is true, as there is no governing body for REST. However, there are best practices that should be followed. We're going to talk about those here in just a bit. And as long as you follow them, your API should be totally awesome. I will tell you right now, the first mistake people make is they do not plan for their API. They say, I'm going to build this API, I'm going to throw my services in there, I'm going to jump into it, and they don't do the planning phase, and it bites them in the rear later. So that's going to be the most important thing we can do, is plan for what we want to do and what needs to do in the future. Last but not least, REST services are not reliable. You know, again, a lot of this was like, well, the calls and the returns. As long as your end user is properly catching exceptions and properly catching the HTTP response codes, it's perfectly reliable. The problem is that REST is still new to a lot of developers where they're not exactly sure how to use these response codes. They're not sure what these HTTP headers are. And for that reason, you might want to have an SDK that really simplifies the process for them. So a good REST API offers several different things. The first is generality. It's language agnostic. We're at a PHP conference, so I'm going to get hanged for saying this, but you don't want to create a REST API that's designed for PHP. You don't want to create an API that's based just for Java or goes in convoluted. You want something that's very simple, easy to use across all platforms. You can make your SDKs language specific. You want familiarity. You want developers to look at and say, I can use this. You don't want a developer to go to your developer portal and say, what the heck is this? How do I do a simple call? How do I get a stock price, for example? Make it very, very easy, and that's why we want to follow the standards. Scalability, you want to be able to grow with your users. The last thing you want to do is build an API, get a whole bunch of people start using it, and then get the Twitter message of death saying, hey, yeah, our servers can't handle the load, because you want to really build your reputation. Segmentation, sections can be updated independently. How many people have ever updated something and it updated like 10 other things that you didn't want to touch? It happens all the time in our code where we have all these methods and all of a sudden it does a whole bunch of magic we didn't know about. We want to avoid that as well. So make sure that everything's very specific and explicit in what it does. Speed, using low data transfer, making it catchable as much as possible. Security, again, personal data should remain secure. And then encapsulation, ability to send data as objects, especially if you're using a SDK, because then you can take those objects, expand them, and have everything right where you can use like ORMs and stuff to actually map it back when you save the data. So again, the big thing here, and really the only reason I'm showing this picture twice is because it took me 4 hours to make it. And I'm not a graphic designer, so I was really proud of this. The API is going to be talking, but we do not want them to have access to the other information. We're going to say, hey, it's basically like you go to a website and you say, you log into your account and say, I want this information. That's all you get, nothing else. Same thing with the API. So a good REST API is going to use explicit HTTP verbs. The acronym for that would be CRUD. We want to create, read, update, and delete. Very simple. We don't need anything more than that. And the verbs we'll use for that, for create, we'll use post. For read, we'll use get. For update, we'll use put, although you can use patch as well. The difference between put and patch is put is usually designed as a complete update, where we'll replace all the data. Patch is a partial update, where if you only send a first name, last name, it'll only update the first name, last name, and not delete the data for the remaining fields. Keep in mind as you're building this, fun thing about REST, a lot of developers look at put and patch and they're not quite sure what is the difference between the two. And so if you do that, we want to have documentation that says this is what this one does, this is what this one does, otherwise you're going to get a lot of support calls. And then delete is super complicated. You just use the delete method. A good REST API is also built to last. One thing I really do not like with APIs is versioning. People will go to a website. You don't go to yahoo.com/v1. You go to yahoo.com. And the problem is with versioning is sometimes you have to break backwards compatibility. Sometimes you have to say, look, we have to move on because we've made a major upgrade to our system. But as long as you're within the same system, you should not have these backwards compatibility breaks. So thinking long term where, hey, we're going to make sure it works no matter what we do, and we're going to expect the unexpected. My favorite statement by Al Gore, we have to expect the unexpected. As Dr. Roy Fielding, really the guy who came up with the whole REST theory, said software design is on the scale of decades. So often when we're building, we're on these tight timelines where it's like, okay, I have to have this product done in the next 3 weeks, otherwise my project manager is going to freak out at me. Well, we have to do that. The most important thing with an API again is not just being good at the short-term design, but the long-term design and making sure that what we do will last us, and so we don't have to go back and break backwards compatibility. Because I'm going to pick on Constant Contact because it's fun. Back in May, we launched our V2 of our API. We now have a V1 and a V2 we have to support. And we have a whole bunch of users who call and going, well, I'm trying to use XML on V2. I'm trying to use JSON on V1. It's not working. What am I doing wrong? And you cannot say you're an idiot because then they get mad at you. So you don't want to have these issues. A good REST API also uses Hadias, or hypermedia, as the engine of application state. This was written by a doctor, because it's like, I have no idea what it means. Hadias basically relies on the concept, again, that your application will change. Your data is going to change. Even the paths that your users use to access your API are going to change. So that's fine, but these changes should not affect the user. They should be seamless to our users. When you update your API, your end user should not have to run into their code and update their code. How many people like doing that? When API changes, everything breaks, your customers are calling, going, what's going on? Did you build it wrong? You have to run in, change the code. So in this case, what we're going to do is we're going to stress hypermedia over a service-oriented architecture. So we're not going specific. We're not going, hey, I'm going to make this call. These are parameters done. We're saying we want dynamic content being sent back and forth between the users. So the way we can accommodate this is we're not going to send back the data that they request, for example, a user object, but we're going to send back the next options that are available with that data. So we're going to send back a series of links. The nice thing about this is if I want to edit the user versus having to have a hard-coded link and typing it in, and then once we change that path, it doesn't work, I just grab that link dynamically, just submit it, done. Very, very easy to do, and it helps prevent having a v1, v2, v3, v10. So a good REST API, kind of the standard that you want to follow for that is HAL, or Hypermedia Application Language, which is just a very simple array object within your return result. And you can use the content type of application HAL plus JSON to really specify this is what I'm returning. But it's actually a very simple concept, very simple to do. In this case, we're just having a links object or array, and we're saying, hey, if we want to edit the object, this is the URL you're going to use. If you want to send the user a message, this is the URL you're going to use. By doing that, we're now able to change things without breaking backwards compatibility. So let's say we want to require the last name just because people can get spam, they're typing in the wrong ID. We can do that very, very simply by just changing that URL. Of course, our end users and SDK is relying on the message key here to get the information, so there's no backwards compatibility break. Works smoothly, continues without any issue whatsoever. Any questions so far on kind of what makes a good API? HAL, HADIAS? You could do that as well, yeah. Like StormPath has a great API where they do a great job with this, where you send your first request and then it's like, okay, get directories, get applications, and really walks you through what your next process or step would be. It depends on how your application is architectured overall. But think of your API as a website. When somebody logs into their website, you don't say, okay, now type in the URL of the place you want to go. You give them the exact links to where you want them to go. That's kind of the same concept with HADIAS and creating a dynamic API. It's really transitioning from, we're writing code and we're developing it, and here you go, this is what you get, and it's static, to, hey, you're in a dynamic website now where I control what you can do, and if I have to make changes, we can make those changes seamlessly and without affecting your users. Okay. Also, you want to use JSON instead of XML. You can offer both, but your primary should be JSON. The exception is maybe you have a large client base that's been using XML for years. In that case, you'd probably switch your primaries, but JSON is just a better alternative to XML. First of all, there's better language support. It's better supported in Java, in PHP, in Ruby, JavaScript. All support much better than they do XML. It's lightweight. Again, you're saying a lot less code. It's object-oriented by nature, so instead of having to try out like something like simple XML to break it out, or DOM document break it out, you can get it, just say, hey, JSON decode, and now you have your entire object all ready to go. And again, very simple in PHP. You have the JSON encode, JSON decode. Very simple to do. That's a good question. I don't know that one off the top of my head. Does anybody else know the answer to that? The other thing too is a lot of frameworks already have JSON libraries built in. Like, I'm not going to do advertising for Zend Framework 2, which is so much better than Symfony. Any Symfony users? Okay, I'm just going to stand over here. Zend Framework 2 has an awesome JSON parser in there as well, where we'll say, okay, try this out. If there's an error, it'll throw an exception, let you know right away. Symfony 2 also has very good parsers, so. Use authentication tokens or API keys. A lot of people like to create this nice open API. The problem with that is you lose control once you do that. And so if you create this API and it's starting to be abused, well, how do you stop that? You go in there and you block the IP, and they switch to a different IP. Whereas if you have an API token, it gives you more control over who's doing what are they doing, are they trying to access pages they shouldn't be, are they overloading your server, and it really helps you understand your users and also keep them from destroying your application as a whole. Use OAuth tokens, and they should be linked to API keys instead of using usernames and passwords. One of the big issues with this is that if you use a username and password and I hack your script, I now have access to everything that user would have access to on the control side. So if you create an API that allows them to send emails, for example, well, now I can log in and also modify their billing information, change their account plan, delete everything, and not good for your users. So it's just a good security step to use an OAuth token that's linked to an API key, and that should be a very specific link. You should have an individual OAuth token per API key and not mix and match. Throttle API key usage. And the first time I said this, I got this weird look, like, why would you want to throttle your users? Don't you want them using your API? And the answer is yes, you want them to use your API, but you don't want them crashing your server. And when I was younger, I may have got myself in trouble because I was creating this website, and I wanted to get more visits to my website, so I put the JavaScript pop-up code in there. And so I tried it out, and sure enough, popped up, and it was awesome, and it was like the best thing ever. I was like, next day I had 1 million hits. And I was like, wow, this is really cool, but this isn't right. And so I went and looked at my code, and that pop-up would launch a new pop-up, which would launch a new pop-up, which would launch a new pop-up. And I had some very nasty emails in my inbox saying, screw you, you just crashed my computer. The point is, it was completely by accident. It wasn't malicious. I was trying to do one single pop-up, but it was just a developer making a mistake. And if a developer makes a mistake where they create an infinite loop accessing your API, they could do a lot of damage. So we want to watch out for things like that. It also helps prevent us from DOS attacks that are deliberate. And you can have different levels. You have that API key. You could say for this API key, they need 5 hits per second. For this API key, they needed 10 hits per second or 10 requests per second. So you can give them individual throttles to really accommodate your users' needs without having to worry about what happens if user XYZ gets 1 million hits per second all of a sudden, and I don't have the bandwidth to accommodate that. And of course, you can always use the cloud. That's just the buzzword of like the entire year, so I wanted to use the word somewhere to help with scalability as well. Again, OAuth tokens prevent the misuse of the system and limit access to the control panel. One of the worst things you can do is store usernames and passwords to third-party services. Once you store that, you're actually opening yourself up to a liability because let's say you're doing an API call with Amazon and you store their username and password for that. And then I go in, steal the information, and do $10,000 worth of purchases on Amazon. And I do that for every one of your clients. Chances are people are not going to be very happy with you guys. So use OAuth tokens, keep their username and password off the database and out of sight. Also, you want to use HTTP status codes. I cannot talk today. When you create a new item, you're going to want to use 201 for created. When you just do a simple GET request or an update or a delete, you're going to want to use 200. It was OK, received, did it, no problem. 304, hey, for whatever reason, this object was not modified. Maybe they sent a parameter and we couldn't access the database. Maybe it was just the wrong parameter saying, hey, we didn't modify it. Maybe it was duplicate data, so nothing changed. Let them know nothing changed. 400, bad request. 401, not authorized. 403, forbidden. 404, page not found. Yes, that's my favorite code in the world. 405, we use quite a bit as method not allowed. That's if they try to do something. Maybe they want to delete a user and they're not allowed to delete the user. Method not allowed, don't do that. And then 500, internal server error. There are a couple status codes you probably don't want to use. The first one, unless your server is actually a teapot, don't use 418. And then despite the popularity of 420, and if I was in Colorado, I could have so much fun with this. That's not the correct status code for you're making too many requests. You'd want to use 429. 420 is intended to be satirical. Also, and this is my biggest pet peeve working with APIs, please, 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 please use descriptive APIs and give me more information. When you give me an error message, say, hey, this is the problem, this is why it's a problem, and here's how you fix it. Because the last thing I want to do is go search through thousands of pages on Stack Overflow and spend hours upon hours trying to figure out how to fix it because I'm missing a simple parameter. So give descriptive error messages. These are not descriptive error messages. And these are all error messages I've seen. Something went wrong. No. Could not complete action, invalid parameters, and hey, look, it's a rocket. This is not the time to be funny because I will come find you and be like, hey, look, it's a rocket going through your window. I want to know what the problem is and get it done. So the authentication token is not recognized, or it's invalid. Learn more, giving me a place where I can find the solution. A user ID is required to perform this action. Learn more. I could even live with error code 313, read more, but then tell me what error code 313 is and how to fix it. The nice thing about this is you also have living documentation, which allows your users to constantly stay up to date, understand what's going wrong. And again, I don't have to go dig through thousands and thousands of pages and Stack Overflow and have that one guy go, you're an idiot, because that's what they usually say to me. You know, quick, easy solution. And remember, please, 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 please do not break backwards compatibility. Again, you're going to create problems for your clients, and they're going to think of you like Facebook, and that's usually not a good thing. It's ideal to have unit tests running against your API to ensure that changes do not cause negative or unforeseen consequences. How many people use unit tests? Unit tests, yeah. You want to use them, and you want to have them on every endpoint. And it seems like such a silly thing, you know, like, oh, well, what could possibly go wrong? We released an API update, and it was a quick, minor change, no big deal, and we didn't write unit tests for that one section. And a week later, I got a call at 1 o'clock in the morning going, my API isn't working. And I had about 1,000 emails in my inbox next morning saying, my API isn't working. That minor, tiny little change broke a different part of the API. Had we unit tested it, we would have known. Something we got corrected right away. But you know, the thing with APIs is developers depend on it. It has to be reliable. Versioning. I'm going to get myself in trouble for saying this. I'm going to descend from the popular view. I hate versioning of APIs. I think I've said it like 20 times. I'm going to say it again. Users should not have to go to api.yourwebsite.com/v1/v2/v3. It happens. You're going to have major compatibility breaks. You're going to have major version releases. But try to keep it as simplified as possible for your users to avoid having them to figure out, am I on v1, v2? Because I have to find different documentation and deal with that as well. Okay, any questions on that? Everyone's still awake? And he's like, yes, barely, we're good. So, how many people here were for the ZF2 intro? Anybody take that? Okay, so I'm going to go through the next few slides fairly quickly then, because a lot of them are going to be recap. But we're going to really kind of assume that you don't have ZF2 installed. And then we're going to assume that you're going to be using Git, which, by the way, not to do another shout to sponsors, GitHub's a great resource, so use them. That you have Composer, and of course that you have PHP on your server. So really to create a very simple project using the bash, make directory, we're going to call it API project, change into the API project, just change directory. We're going to create a Git repository, Git init. We're going to add the Zend skeleton application, Git pull source master, and then we're just going to use Composer to install that. That's really your quick 2-minute install for Zend Framework 2. Once you do that, you'll have your Zend Framework 2 page. Whew, if you don't have this, something went wrong. Then once we do that, we want to set up the view JSON strategy. So in your view strategy, in your module config, and for those of you who haven't used Zend Framework 2 before, you'll just go to module application config, and it's module.config.php. Under view manager, you'll find strategies. If it's not there, you can go ahead and add that, and then I'm just going to add the view JSON strategy. What that does is it tells the Zend Framework application that we can now use JSON to return a JSON view model. We also want to add our controller to make it invocable. So let's do invocables, application controller. In this case, I'm doing a call for a user. So it'd just be the user controller. Again, probably a lot of review from the last session you guys just took. We'll then need to set up our routes. For API calls, you're going to use segment, set up your route, and then set up your controller. One thing you do not want to do when trying to use an API is set up a default action. Because if you set the default action, it'll actually override the abstract REST controller, and it'll take you probably a lot less time than it took me to figure it out, but it's very frustrating. So no default action in there, just use your controller. Okay, once that's set up, we then want to use the abstract RESTful controller. The great thing about Zend Framework 2 is it makes it very, very easy to create a REST API. All the information we need has already been set up in this controller for us. So what we'll do is just say, we'll extend it. The methods that come within this controller right off the bat, there's create, there's update, there's delete, replace, delete list, patch, get, patch list, get list, and options. And what these do is they allow you to either update a singular item or multiple items. So for your create, this allows you to create a new object within your API. And if they send a post request, it'll automatically go to the create method for you. The next one, update, actually go down the list, delete. Same thing. If you send delete with an ID, it will say, OK, I'm going to delete a singular object, and it will take them to that method. If you just pass a delete call using the delete HTTP verb, it'll take them to delete list. This is one method you probably don't want to enable. For example, let's say I go to api.yourwebsite.com/users. I make a delete call. Basically, this would be delete the entire collection or delete all the users. And chances are that's not what they're intending to do. So really try to avoid the delete list method. Get, just a simple get call if there's an ID. If there's no ID, it will then transform to get list. Again, this all happens very automatically for you. For a put, it will go to update. For a patch, it will go to patch. And again, you can see if it has the information, if it has an ID, for update, it requires one. For patch, it will require ID, but if there's no ID for patch, you can actually update the collection. Great example for using patch list would be if you want to add new fields or new parameters to each individual item. And then options, which just returns the options back for what you can do with this API endpoint. So setting up the user controller. In this case, we're going to create our user controller, an application controller, user controller. And the first thing we want to do is set up the options. Then we're going to create an event listener. And then we'll start building our API methods. So to do that, we're going to use our namespace application controller. You'll notice that we're going to call in two very, very important sections here. The first thing we're going to call is the abstract RESTful controller so that we can extend that and have those methods there automatically for us. And then we're going to use the JSON model to view or return JSON to the users. And then, very simple to implement, user controller extends abstract RESTful controller. With this code right here, just like this, what would happen if I made a GET request to this application, do you think? It would go to the GET method within the controller, the GET list method. And by default, each one of these methods is going to return 405. It's not allowed because you haven't defined an activity that they can do for it. But right here, just with this code right here, we now have a endpoint that will use REST that we can actually communicate back and forth with them. So we want to do some stuff. We're going to set up the options. This will allow us to know what options are available. We're just saying, hey, for collections, we're going to allow get and post. We're not going to let them delete a collection. We're not going to let them patch a collection. And then for resource options, we're going to allow get, put, delete. We could probably add patch to that one if we wanted. And then we're going to say, hey, these are the options. Return those collection options if there's no ID. Basically telling the user this is what you can do if they request it. And then we can use the get options method and the check options methods. To return the available options, and here's where we're actually taking that code. When we use the options method or the options call, it'll just be get the response. This is what we allow. It comes back as a header saying these are the types of headers that are allowed or to make your call with or what you're trying to do. We can add the event manager. Pretty easy to do. We're going to set event manager, use the event manager interface, events, this events, and then we'll attach on dispatch check options, make sure it's something that they can do. Again, if they try something and they're not allowed to do it, it'll still go to the abstract method and say, hey, you're not allowed to do this. So even without this, you can still create the API very, very quickly, very easily. It's just kind of a nice little quick shortcut. And then there's our check options where it just says, hey, if it's not allowed, give them the 405 right down here. Otherwise, just return do nothing. Again, this is more about, can I do this? Yes, awesome, or no, you can't. So add your action methods. If we want to modify the data when it's created, we have our create method here. So create, give me the data. In this case, we're just grabbing a service locator to grab our user API service. You can do whatever service you want in that case. Ideally, you want your API to use your main services to keep everything uniform. You can extend your services with another service, but you want to keep the data as routine as much as possible. What that will do is allow you to scale your API without having to go back and change a lot of code. And then, of course, because we're doing a create, we're also going to update the status code to 201. And then there's our JSON model where we're saying, OK, return the result as JSON. So with this code, if we make a curl request, we can look at that and say, OK, I want to post data. Our content type is application JSON. That will return the JSON back when triggered. This is the API URL we're using. But you'll notice that we get, first of all, the 201 created as a response. And then we can see the data comes back very nicely in JSON. And then we also have our Hadios in there. Zend Framework 2 by default does not incorporate Hadios. That's something you have to add the data for yourself when using the API. The update method, same thing. We want to update something. We're going to send the ID, data, get the service locator, and then we're going to say, hey, this is the ID we're going to update, send the data. If it's successful, set status code to 200. Very, very simple to do, very easy to do, and then return the JSON result for that. And we see a very similar situation to what we saw with the post. Delete list. Again, delete list is not something we want to allow. So we can do the whole 405 and just say, hey, this method's not allowed. Or we can give them more information. In this case, we're sending it to 400. And we're saying, here's the reason. There's a code we're sending just in case you use codes with your API. So they can look up the documentation, say, this is the code response I got. We're giving them a nice, clear message. Hey, a user ID is required to delete a user. You can't just call delete without an ID. And then more information. If you want to find more information on how to do that, go to this URL, and you can look it up and get the information that you want. And if we do a delete request, then not without an ID using curl, again, follows along those lines. 400, bad request. And it'll tell us all the information right here and give your user a really good chance to say, OK, this is what went wrong, and explain to them what they need to do to fix it, making your developers' lives much easier. So with that, you now have a functional API. In the Zend intro session, they show them over services. You're just really building a Zend Framework application, pulling in that information, and then using the abstract layer to really control it and create a nice API interface for you. There are a lot of other tools that you can do as well. Apogee just came out, which is really a type it in, and it creates the MVC for you and actually says these are the endpoints for you as well. Very nice tool. This guy right here could tell you more about that if you want to talk to him afterwards. There are more methods in the abstract RESTful controller, but honestly, those aren't ones you're going to have to worry about. These are going to be your main methods that you want to work with and use. And remember, you want to use features such as OAuth 2 and throttling. You can do that by creating your own abstract class, throwing it on there. If you want to use PHP 5.4, you can actually throw a trait on there to make it even easier, not have to extend the abstract RESTful class again. And then you can take advantage of, there's actually a really nice Zend Framework 2 REST skeleton app already on GitHub that you can use for this as well. More resources, and I'll post these slides online, but there's a great REST tutorial. I love the URL for this one. It's just restapitutorial.com. Apogee has a nice REST design PDF that they have out their white page. ZF2 getting started to learn more about using ZF2. Matthew Wirro-Finney's ZF2 REST tutorial, and then Hound Dog's ZF2 REST tutorial as well. And just a final thought. A good REST API is difficult to use. Like, people don't want to hear that, but that's the truth. If you design your API, it's not something that somebody who's pulled up a PHP book, spent an hour reading, is going to be able to do or truly understand. But a good REST API is designed for longevity and to perform complicated methods and to evolve with time. For that reason, SDKs. Build an SDK for your API, have SDKs out there. They do save lives. All the time I get a call going, how do I use this API? I say, what language? Well, PHP. Download the PHP SDK. In 5 minutes, like, got it. Versus trying to explain, okay, this is how you do a curl request. This is the information you have to pass in the headers. Have a nice SDK out there. With that, I'll leave the rest of the time for questions. I just going to, again, give a quick shout out to Constant Contact because they made this presentation possible.